Hello and welcome to Physixify once again. In the previous video, you saw that we were covering the theory on potential energy. So, in today's particular video, we would be seeing some of the problems. Problems hashtag 1, right? So, let's quickly take a look into question number 1. We have 3 questions to do. First one says that there is a variable force given to you as 2x. You also know that this is a conservative force because Fc, the subscript, is given to you. Next thing that you also know is that potential energy is 10 joules at some x equal to 1. Now what is it that you are required to find? You are required to find the potential energy in joules at x equal to 2. What will you do? You use the same logic that we told you in the previous video, that steps to solve a question whenever it's given related to potential energy, you'll say delta U equal to minus WC or U final minus U initial as minus WC. What is the next thing that we can do? We can see that at x equal to 1, 10 joule potential energy is given. At x equal to 2, it is asked. So let me say that let us consider that this is the final scenario, and let me say that this is the initial case. So the next statement that I'll make is u2 minus u1 as minus wc. Why? Because u at x equal to 2 is required, which is my u final, and u at x equal to 1 is given, which is my u initial. This is minus wc. Now what I'll do is I will put this thing as something as f dx or fc dx, because that is where I can use the initial thing fc given as 2x. So next thing that I do is I put in u2 minus u1 as minus integral f dx. You can also say minus fc dx, it's the same thing. And next thing that you know is I integrated from 1 to 2. From 1 to 2, why? Because initially I was at x equal to 1 when I was having potential energy as 10 joules, and x equal to 2 I want to find out. So on solving, I would assume that you can reach from here to here. I've only cancelled out 2, that's all I've done. And the next thing, after putting the values, you get this thing is, you see, repeated over here. This thing can be put as minus of 2 square minus 1 square, which would be minus 3. So you will get u2 minus 10 as minus 3, and you can put down the value of u2 as 7 joules. This was the first question, right? Similar questions can be put up, so let's try to find out those as well. So if we see question number 2, now what happens is you are being told your conservative force has changed from that 2x to 3i plus 4j. It's given to you in vector form, if you would be so kind to notice. Next thing, you know that u at 0 comma 1. What do you mean by 0 comma 1? This means at some x, at some y, your potential energy was 10 joules. Initially in the previous question it was 10 joules at x equal to 1. Now it is at 10 joules once x is 0 and y is 1. What is the next thing we need to find? We need to find the potential energy at 2 comma 3. This means once your x is 2, over here x is 2 and y is 3, what would be the potential energy then? So how to do this question? This question is going to be run on the same pattern because the steps must remain same. It's just that the calculations might get a little tough. Let's try to decode. First thing I'm using is uf minus ui as minus wc, which you already know the definition of potential energy, or rather the change in potential energy. The next thing you can put is that let us say that this is my final case. I'm gonna put down this as final case, and I'm gonna put down this as the initial case. So you can directly put uf minus ui. You directly put ui is given to me as 10. I'm gonna do u of 2 3 minus 10 equal to minus wc. Now you can get a little bold because you've seen the first question. The next thing, like you integrate, you put wc as f dx. You integrate it well because you know that this is your fx, this is your Fy. All you need to do is you need to see this term very carefully. U2 3 minus 10, this is directly given. This Wc can be said as integral of fx dx plus integral of Fy dy. This we know because work is a scalar quantity, right? So once we put down these values, you know that Fc is given as, Fx is given as 3, Fy is given as 4. So you put down these values, 3 dx, 4 dy, you integrate it well, and once you have integrated it well, you will find out that U23 is your answer, which turns out to be some minus 4 joules. So I hope that you will beg my calculations till here, getting till here. This was important. Maybe putting till here, it was important. But all of this part is mathematics, pure, simple, sheer mathematics and integration. I hope you would be able to do it. Those of you who want to, you can probably pause the video right now and try to solve it and reach till there. In the meanwhile, I'll take you to the next question, and now we have the final question, that is question number 3. I hope you would have gotten an idea that I started with x. I took an example of x and y. So this is an example where all three are involved, x, y, z. Right? You see your conservative force is given to you as x square I plus yj plus z square k cap. It's given to you in vector form. It's given to you as a variable conservative force. And those of you who don't believe that this is a conservative force, maybe you can watch the previous videos where I tell you how to find out that this is a conservative force, and let's say that you know that this is a conservative one. Next thing you are given is that at some x0, y1, z1, your potential energy is 10 joules. So how will you find out the potential energy as at 232? So this is again simple. You follow the same rules that I've told you. You write down initially UF minus UI as minus WC. You can assume that over here this is your UF, this is your UI. So on putting those values, you get U at 232 minus 10 given to you as minus WC. Now you need to put WC as integral f dx, and once you do that, you'll get this big statement coming in for you. This is your fx, this is your fy, this is your fz. This fx you are getting from here, this fy you are getting from here, and this fz you are getting from here. So again, using the fact that work is a scalar quantity, you can put this down. The next thing is only calculations. I'm sure that you would be able to do that. Once you integrate it, put down the correct values, you will get some answer, which I want you to tell me. You can comment your answer in the chat box. Let me know what you find out, and I'll revert as to whether you have done it correctly or not. This was all that we had from this section. I hope you thoroughly loved it. Thanks a lot for joining in with us. If you have had any problems, any queries, do not hesitate to write it down in the comment box. Different links have been given to you in the bio, so you can go out and check those as well. There's some exciting stuff going on, but the most important thing would be that you like and subscribe this in case you did, right? So we'll meet back again. We're gonna do more problems. This is me signing off for now, saying sayonara and take care.